All right, hello, bulky rock stars. We are going to go through in this lesson multiplying and dividing by using scientific notation, numbers that are expressed in scientific notation. So the last two lessons, now you've gone through them and you have a good grasp on how to express numbers in scientific notation and take numbers back to standardized form. So if we have a question now that's dealing with multiplying two numbers that are already in scientific notation, what do we do? Well, one way you could go through and change these into standardized form, and we know that we're multiplying because these are two pretty easy numbers to change into standard form. And then if I were to continue, whoops, don't forget your equal signs, this would end up being 80 million. And if I wanted to put that back into scientific notation, it would be 8.0 times 10 to the 7. Now, there is another way of doing this. So instead of going through the putting everything back into standard form, instead of putting everything back into standard form, there's another way that you can multiply these and see if we end up getting 8.0 times 10 to the 7, because that's what we got when we did it the long way. Well, here is another way of doing this, but what we need to do is refer back to when we worked with exponents. And what do we do when we multiply numbers with the same base? What do we do with the exponents? So when we are multiplying for scientific notation, first of all, we know how to multiply our 2 and our 4. So if we took these numbers, so I took 2 and I multiplied it by 4, then I would be multiplying 10 to the exponent 3 times 10 to the exponent 4. Well, 2 times 4 we know how to do, and that comes out to be 8, okay, or 8.0. Now we're going to multiply it by the power of 10. But here we notice these both are the same base. And we go back to the lesson that we've already learned with multiplying exponents of the same base. We know that our exponents, we can add our exponents. So therefore, if we ended up solving this out, we have 8.0 times 10 to the exponent 7. And this end up being equal. So this is another way of solving multiplication when using expressions as already in scientific notation. So I'm going to give you another question here so you can practice. And this one, we are going to have 2.6 times 10 to the negative 2 times 3.5 times 10 to the 6. You can pause it here, give it a try on your own first, and then I'm going to then come back and I will be solving it for you. All right, so first thing we do, we take our two numbers and we're going to multiply them. Then we are going to take our 2 powers of 10 and we are going to multiply those two. So we have 2.6 times 3.5, and we're multiplying that by 10, negative 2, and since we're multiplying, we know we add, because they're the same base, we add exponents. So when we solve this out, you should have ended up with, if this calculation is correct, 2.6 times 3.5 would be 9.1 times 10 to the negative 2 plus 6 would be 4. And that would be our answer. So that is how we would do when we're doing with multiplication. Now, let's move on to division. And to be honest, division is not very much different. All right. So now what we're doing is we're taking our two scientific notations, and this time we are dividing them. So we do the same same way. If you had put them both into standardized form and then divided the two numbers, you should end up getting the same way as this shortcut. So what we're doing is we're taking our 9.6. So we could actually look like this. 9.62 divided by 1.84. And then we're dividing this by 10 to the 7 divided by 10 to the exponent 4. So if we did that and we took out our calculator if you need, and we divided these two numbers, we would have gotten 5.228. Oh, sorry, I put a division here. That should be times. My bad. Times. Now we're dividing two numbers with the same base. So what do we do with their exponents? Well, going back to our previous lessons, we know that we would subtract the two exponents. That would end up turning our number into a 3. But let's first deal with this here, because this is we could probably reduce that. Round that. So this could be rounded to 4.2. Well, let's see. We have the 2. Look at the neighbor. 8 is over 5. So that means it bumps up this number to a 3. And we multiply 10 to the exponent 3. And that would be your answer. So we're doing the same thing. We're taking our two numbers, we divide them, and then we're multiplying by our two bases, which we would divide those as well. And then we would end up. So I'm going to give you 2 more questions just for you to try. So I would suggest when I write them down, you write them down, and then you can, solve them. So I would stop the tape. So we have 2.9 times 10 to the 2, and let's multiply that one by 3.2 times 10 to the 4. Okay, so you can pause it here, give it a try, and when you have tried it, your answer should end up being 9.28 times 10 to the exponent 6. So I multiplied the first two numbers, then I multiplied my power of 10, which I would add my exponents to get 6. I will now give you a division one for you to try. So you have 4.6 times 10 to the 12 divided by 1.9 times 10 to the exponent 7. So you can pause that, give that one a try, and you should have ended up dividing 4.6 and 1.9 to get 2.42, and multiplied by, divide 10 to the exponent 12 by 10 to the exponent 7. You subtract the 2 because we're dividing. So it would end up being 10 to the exponent 5. All right, so when I see you on class on Monday, you will have some other questions to practice with this. And then I hope you enjoy your weekend.